Hello friends, welcome back to this NPTEL online certification course entitled Soil and Water Conservation Engineering, and I am Rajendra Singh, Professor in Agriculture and Food Engineering Department, IIT Kharagpur, and we are in lecture 4 of week 1 and the topic today is the soil erosion mechanics. Just to remind you the course content of this week, in the first lecture we introduced what is soil and water conservation. In lecture 2 we talked about the causes and types of soil erosion. In lecture 3 we discussed the factors affecting soil erosion and effects of soil erosion, and today's lecture will be devoted to soil erosion mechanics. And in the last lecture of the week, that is lecture number 5, we will discuss the water control erosion measures. So, let us start with soil erosion mechanics. We know that water erosion, there are two major agents of soil erosion, water and wind, and the soil erosion by water that is referred to as water erosion. We have been seeing this in previous classes also. Now, there are three processes involved, or it is a 3-step process, or 3 processes are involved in the soil erosion by water, and the processes are detachment of the soil particles, that is process number 1, then transportation of the detached soil particles, that is process number 2, and deposition of the transported material, that is process number 3. So, soil erosion by water, which is referred to as water erosion, is a 3-step process: detachment, transportation and deposition. So, we start with the detachment, or if we continue with our discussion, then the driving forces behind water erosion process are detachment, of course, and then is transportation. That is, there are two major processes, detachment and transport, and the driving forces of detachment are raindrop impact and flowing water, and for transportation it is the flowing water. So, remember we discussed right from lecture 1, when we started classifying soil erosion, then we started with the classification of water erosion, and the first was raindrop impact erosion, and we said that that is the first level where erosion starts, and that is when the raindrops, again I repeat, when the raindrop hits the soil surface, because of their velocity or because of their kinetic energy, they hit the soil surface hard and they break the soil aggregates, and once the soil aggregates are broken, the soil particles are because of the impact, the soil particles get splashed all around, and this during this splash process, that is nothing but detachment of the soil particles. Detachment of soil particles takes place, and simultaneously another phenomena is occurring when the rainfall is occurring. Simultaneously another phenomena is occurring, that is the rainfall. You know that when on a soil surface, if you see the soil surface, and when the rainfall occurs, then obviously first process that starts is infiltration. So, that means soil, the rainfall will first satisfy the infiltration requirement of the soil, and once the infiltration capacity of the soil is satisfied, then whatever rainfall occurs, that will fall, that will flow horizontally, and that is referred to as, we refer to that as overland flow or runoff generation, and this flowing water, whatever detailed soil particles are available here, this flowing water will carry that away. So, and also during the process, during the flow process, this soil particle, this flowing water, because of its kinetic energy, it will also detach soil particles from the soil aggregates. And of course, as we already mentioned, the flowing water will transport whatever loose materials or detached soil particles are available. So, that is how there are two major driving forces of detachment. Behind detachment transportation are raindrop impact and flowing water. And the third process which will takes place is deposition, that is when there is the carrying capacity of the flowing water reduces, then obviously it cannot further transport the soil particles and thus the soil particles get deposited. So, that is the third phenomena. So, detachment and transportation, the raindrop impact and flowing water are responsible, and when the carrying capacity of the flowing water reduces to a large extent such that it cannot further carry the detached soil particles, then the soil particles get deposited. If you look at a hill slope once again, and if you just imagine that a single raindrop is hitting the soil surface, and because of this hit here, as you can see that soil particles are getting splashed everywhere, and in the process obviously there will be loose soil particles available on the surface all around. Once the infiltration capacity is satisfied, then obviously the overland flow process will take place, and then the overland flow process will take place, and that will take the detached soil particles further away. At the same time, because this flowing water has a high velocity because of this slope, so it will further detach the soil particles. So, that means as you can see that detachment and transportation are occurring up to this point simultaneously, because it is not only the raindrop impact, but also the flowing water detaches the soil particle and the flowing water transports the soil particle. So, that means simultaneously detachment and transportation phenomena are occurring. But when we reach the valley bottom where the slope is drastically reduced, then obviously because the flow velocity reduces, then the carrying capacity of the flowing water will be less, and because of that soil particles that are being transported from upstream, they will get deposited here. So, that is where deposition is taking place. So, this is the entire mechanics of water erosion. The severity of erosion depends on the quantity of material detached and the capacity of eroding agents to transport it, which is quite obvious because these are the two processes involved. So, based on this, erosion could be detachment limited or transport limited. When the capacity of the transport exceeds the eroded material, then it is referred to as detachment limited. That means, there are not enough detached soil particles for the flowing water to transport along with it. On the other hand, when eroded material exceeds the transportance capacity of the flowing water, then it is referred to as transport limited. So, that means the severity of erosion depends on quantity of material that is detached and capacity of eroding agents to transport it, and based on whether the transport capacity is more or the eroded material more, it could be detachment limited or transport limited. Now, coming to detachment process. Several times we have seen this, but once again let us repeat this, that raindrop impact owing to kinetic energy is the primary cause of particle detachment. So, that is the major reason. Of course, we saw that it is the flowing water that also detaches soil particles, but it is the raindrop impact that is the primary cause. And the impact of raindrops, this shatters the surface soil aggregates, that is the first phenomena that occurs, and obviously once soil aggregates are detached then shattered, then the soil particles get detached from them. And as you can see that here and surface changes here, as you can see here it is much more soil is there, but here as you can see most of soil has been shattered or soil aggregates and been shattered and probably splashed all around. And raindrop can splash soil particles, moving them up to 1 meter away. That depends on the kinetic energy and as already we saw, the slope wind and the sloping land could also have impact on it. So, the ideal case is that when there is vertical rainfall and vertical rainfall falling on horizontal surface, vertical rainfall horizontal surface, then obviously as you can see that the splash is uniform all around. But there can be two more cases, that rainfall is vertical, but land is sloping. In that case, on the downslope there will be much more splash as compared to upside. Similarly, the surface could be horizontal, but the rainfall itself could be inclined because the wind impact, which already saw in the previous class. So, because of wind impact, if rainfall impacts the soil surface at an angle, then depending upon on which side angle is being formed, because of the velocity components, the splash will be more on one side and lesser on the other side. That will depend on what is the wind velocity and what angle raindrop is hitting the soil surface. And this detachment not only happens because of the raindrop impact effect, but also the soils could be broken by weathering process, by alternate wetting and drying. So, if the soil is such that there is a rainfall, the alternate wetting and drying is there, then natural weathering phenomena will take place and soil particles gets broken. And of course, if it is the tillage operations we take, or there is a trampling of by people and the livestock, then also soil gets disturbed. Yesterday we saw that how human impact soil erosion, and we saw the primary implements when we use the plowing etc., then we will keep a lot of loose soil particles on the soil surface, making the area prone to soil erosion. Similarly, if you see, you might have seen the sidewalks on the bare soil. That means, if it is a grass area, but continuously people move or animals move or livestock move, then you see that the soil automatically the particular passage becomes bare, and that is because of the trampling by people or by livestock, soil gets detached or gets eroded. And of course, during this detachment process already we have discussed that some of the detached particles, they will seal the soil surface and reduce the infiltration, and once the infiltration rate exceeds the infiltration rate of the soil, excess water will run off in the form of overland flow, and obviously this water will carry away the detached soil particles. That is what happens in the case of sheet erosion. And in case of detachment, the kinetic energy of the rainfall can be estimated by a formula given by Schmier and Spieth in 1978, and as per this equation, E, which is the kinetic energy in million joules per hectare millimeter, that is related to rainfall intensity I in millimeter per hour by this equation, that is E equals to 0.119 plus 0.0873 log base 10 I, and as it is an empirical formula, then obviously if you want to use this, you have to remember that E will always be, or kinetic energy will always be in million joules per hectare millimeter, and rainfall intensity has to be used in millimeter per hour. We have also seen that in general soil detachability is directly proportional to soil particles. That simply means that sand is easily detached as compared to clay, because sand is larger in size, so it can be easily detached. Coming to transport, the detached soil particles are carried down the slope by runoff, and the overland flow is the dominant transportation agent. We saw that in one of the earlier slide, we saw that both raindrop impact as well as overland flow can cause detachment. But in just previous slide, while talking detachment, we saw it is the raindrop impact which is the primary force behind detachment. Similarly, we can say it is the overland flow which is the dominant transportation agent. So, once the detached soil particles are lying on the soil surface, the overland flow takes these soil particles away, and water flowing in rills and gullies is the next important agent. We also saw that rills, what are the rills and what are the gullies while classifying the water erosion. That is, rill erosion is a form where we have a finger like structures and water will have a tendency to flow through these rills and cause erosion. Similarly, gullies are much larger in size. We also saw that they could be U shaped or V shaped in previous class, and obviously water flowing in these gullies also will transport soil particles. The quantity of sediment and the distance they are carried depends on the flow velocity and runoff volume. That means, the carrying capacity of the flowing water, either if it is a velocity of flow has to be very high, or the total quantity of water has to be too high for the erosive capacity of the flowing water to be high. And if that happens, that is either flow velocity is high or runoff volume is high, or if both are high, then obviously the sediment will get transported in a much larger quantity, and they will be carried away to a far off places. And smaller particles, that is clay, are readily carried as compared to large particles or sand particles. So, once again, detachment, it is the sand which is usually detached, which is larger in size, whereas clay which is smaller in size, that is easily transported. Now, if we look at the soil movement or soil particle movement during transportation, then this is how, if this is a water body and this is the direction of flow already shown, then obviously on top of the surface there will be some dissolved sediment particles that will be floating, and of course, some particles will be suspended. So, a major phenomena that occurs is suspension. Then the smaller soil particles, they move by bouncing, that is, they bounce and then again they are taken away in the water and then again fall back. So, that happens with the smaller particles, and that process is referred to as saltation. And if it is the larger soil particles, they are basically pushed or rolled along the stream bed. As you can see here, a very large particle that is being rolled along the stream bed, and that is referred to as traction, and sometimes it is also referred to as bed load movement. So, in the soil water erosion process, the soil particle transport takes place in three different forms: suspension, saltation and traction or bed load movement. These are the three processes involved. If we come to deposition, then basically deposition occurs as the flow velocity reduces, the water loses the energy needed to continue carrying the detached suspended soil particles, and soil particles are deposited at a new location. So, obviously, wherever this flowing water loses its capacity to transport the soil particles further, there obviously whatever soil particles that they are being transported, they will get deposited. And deposition mostly occurs in low landscape positions or at the down slope end of the fields, which is quite obvious, because if we are talking about, just now we saw the hill slope example, we saw that something like this is there. So, here the detachment and transportation were occurring, but once this horizontal surface came, because the flow velocity gets reduced here. So, most of the deposition will occur at this point, that is at low landscape position or downstream end. And of course, placing the deposited material back to its origin can be very costly affair. So, obviously, we know that soil is getting detached at an upstream place, it is being transported and getting deposited somewhere else. Now, if you want to take this soil back to its original position, then it will be a very, very expensive phenomena, and of course, probably it will not be cost effective. That is what it is saying, that placing the deposited material back to origin can be very costly phenomena. And continuing with deposition, deposition could occur, of course, we saw in the downstream places, but if the flow continues, then deposition may also occur in downstream water bodies and cause pollution. So, if the transported soil particles reach a stream or river, then obviously because lot of loose particles and sand and soil particles are being carried. So, obviously, the river water will get polluted. And but there is a plus side also, like we know that sediment can also be deposited in deltas along streams, again where the river joins the sea, and because it loses its velocity. So, most of the soil particles they get deposited forming deltas, but we also know that these deltas are very productive, because they are built from the productive soil, the topsoil which has been carried during the erosion process. So, their deltas are very productive. So, that could be called as a 1 plus of the entire erosion process. And obviously, if you look at the flow, then obviously the gravel sized sediments will be first deposited, sand grains will be taken little far off as compared to the gravel sized particles, and clay sized particles which are much finer, they will be carried further down. So, clay particles can be carried a great distance before deposition, while larger sand particles will be carried only a shorter distance, which is quite obvious, because as the flow gets reduced or the velocity reduces, first the larger particles will get deposited and slowly the lighter particles will get deposited. Now, this is a efficiency of the form of water erosion. This is a data provided by Morgan in 2005. It is 2005 here, and here it says 3 different forms it talks: raindrops, overland flow and rain flow, and it assumes the mass of raindrops is R, and assumes that rainfall mass of R which 50% contributes to runoff, that means overland flow will be 0.5 R and rain flow will be 0.0 R. The typical velocity is 6 in case of raindrops, 0.01 in case of overland flow, and 4 in case of rain flow, which has been estimated using Manning's equation based off lot of experimental data. So, if you look at the kinetic energy, the raindrop kinetic energy will be 18 R, very high, rain flow will be next, and overland flow will be much lower as compared to raindrop or kinetic energy. And as a result, if you look at the observed sediment energy for erosion, obviously which will be higher here, and that is it assumes 0.2% of the kinetic energy of raindrops and 3% of the kinetic energy of runoff is utilized in erosion. Because of that, the rain flow will have much higher energy of erosion. As a result, the observed sediment transport in grams per centimeter is much higher in the real erosion, followed by overland flow and lastly by raindrops. So, that is the data based on the experiments conducted in sandy soil over 900 dredge. Now, coming to up till now we have been discussing about one of the erosion agents, water, but we have already seen that water and wind are 2 major erosion agents. So, now we come to wind erosion, and soil erosion by wind is referred to as wind erosion, which is also a 3-step process. In this case, the processes are initiation of movement, which is caused by wind forces exerted against or parallel to the ground surface. Then we have transportation of the detached particles, which occurs in 3 distinct movements here also, and finally deposition of the transported materials when the wind energy subsides. So, in this case also there are 3 processes. There we called detachment, transportation and deposition in case of water erosion. Here we are calling initiation of movement, transportation and deposition. That is the only change. So, level 1 only has a name change. And if we talk about the initiation of movement, it is caused by wind forces exerted against or parallel to the ground surface. Very similar to the raindrops, if the angle is such that wind hits the soil surface at an angle, then obviously it causes initiation of movement, or if it is a parallel to the ground surface, then also as we saw that even the light wind can roll the soil particles, the rolling of soil particles or initiation of movement takes place. Though the wind velocity is the lowest close to the ground, it may lift lighter and loose soil particles. I mean, even when it is very low velocity, then also the lighter and loose soil particles can be moved or initiation of movement could take place. And the minimum mean velocity which is required to initiate the movement of soil particles, which is referred to as threshold velocity, that varies with soil conditions and nature of ground surface. And for most erodible soils of particle size about 0.1 mm, the threshold velocity is approximately 16 km per hour at a height of 30 centimeter above the ground. So, that is a typical value of the threshold velocity for soil particles of around 0.1 mm, and it measured the wind velocity when measured at 30 centimeter above the ground, then the threshold velocity is 16 km per hour. Then we come to the second phenomena, that is process, that is deposition, and here also like in the case of water erosion, depending upon the size of the soil particles, there are 3 distinct types of soil particle movements: suspension, saltation and surface creep. So, here you remember in case of water also we called suspension, we call saltation, and but in that case we called it traction or braidlet movement, but in this case we call that surface creep. So, that is the only one name change in one of the phenomena. And if we come to define each one of them, then suspension is the most spectacular and easiest to recognize among the 3 forms of movement. It occurs when very fine dirt and dust particles are lifted into the atmosphere, and that is here, that is the lighter particles are taken into atmosphere, and I mean most of the dust storm when we see it is a suspended soil particles we see. That means the lighter soil particles which are taken into suspension, that is more clearly visible to us, and that is the dust storm when we talk about. And suspended particles can travel hundreds of miles depending upon the wind velocity and the size of the soil particles. They can be taken far off from place where the initiation has started. And soil particles of less than 0.1 mm size are subjected to suspension, that is much lighter size or smaller size particles, and it accounts for 3 to 40% of the soil transport. So, suspension accounts for 3 to 40% of the soil transport as far as wind erosion is concerned. Then next process is saltation. Similar to saltation, there it is the movement of particles by a series of short bounces along the surface of the ground. So, the soil particles will move something like that. Particles travel approximately 4 times longer in distance than in height. So, this is 4 times higher than the height they travel, and when they strike the surface again, they either bounce back or knock other soil particles into the air. So, both phenomena could happen, that they fall and they bounce back, or they fall on a soil particle and then make that particular soil particle to bounce. And obviously, it accounts for maximum of soil transport under wind erosion, that is around 50 to 75% of the soil transport in the wind erosion take place due to saltation. And then we come to the last movement process, that is referred to as surface creep, and it is the movement of larger soil particles by rolling and sliding along the ground surface. So, this is here they all either roll or they slide along the soil surface. The particles are rolled across the surface after coming into contact with the soil particles in saltation. So, they can roll because of the kinetic energy transferred by water, or even the saltation soil particles can hit and make them roll around the soil. And the typical particles that have diameters between 0.5 to 2 mm, they are subject to surface creep, and it accounts for around 5 to 20% of 25% of soil particles. So, with this we close this chapter, where we have seen the soil, water and wind erosion mechanics. Just to repeat quickly that detachment, transport and deposition, these are the three processes involved in the water erosion, whereas initiation of movement, transport and deposition are the three processes involved in case of wind erosion. We will continue further and see what can be done further to control this erosion. Thank you very much.